Here comes the moment of truth. Will my rather simple beginner OpenCV code in Python be able to beat the Dancing Machine challenge in the Pikuniku game and do so on the first try? Now let's find out. I'm going to start the script that repositions the window to the top left fixed coordinates, but let's talk about the code later. The game started, let's see.
1, 2, 3, 4.
It starts well, but that was kind of expected because I invested a lot of effort into making sure that my error detection actually worked quite fine on a sample set that I've captured a while ago. Now, seeing how it performs well at the beginning, it's already almost 30 actions and going strong. My only worry is that it may fail towards the very end. It's quite often the case that the script works fine until there's the very end of it where the exit condition or some other condition is wrong, and that's usually very disappointing because everything else works just fine. But there's not too long of a wait remaining until we can see whether this... Oh yeah, that's the difficult part. Yep. And yay! I think 110, and as you can see, the script actually finished already because I knew what to expect. And let's see, did I get the achievement? Yay! Here's the achievement pop-up. 100% on the Dancing Machine on the first try in the Pikuniku game with an OpenCV Python script. Perfect. Now, I also mentioned that this was getting the achievement on the first try. And the reason is that if your score is above the robot score, let's say 64% and you get 65, then you already progress enough for the game to proceed. And as you can see, the game does not actually let you try again for a higher score. So to get the achievement, you must get 100% on the first try. Well, yes, you can also find the save file and make a backup copy and try again and again and again. But I didn't really want to do that. I'm not good at computer games. I'm not good with the controller that could also be used in the game, which is why I decided to give OpenCV and Python a try instead of practicing button mashing on my controller. Now let's have a look at the code. Let me quit the game. We won't need it anymore for the rest of this video. Now, before we look at the code, I would like to thank ClarityCoders, the YouTube channel that actually inspired this entire approach. ClarityCoders channel has a lot of videos on using OpenCV and even machine learning on video games to pass those games and pass the challenges and actually play the games and not just pass the challenges. That was great inspiration for me, so thank you for that and please keep doing that. Maybe you inspire more people along the way. Now, initially, I wanted to copy one of the projects from ClarityCoders and then just modify to make it work for the Pikuniku Dancing Machine challenge. But in the end, I ended up writing all of the code. So this is actually all from scratch. Now, let's go through the code first, see how it works, and then I will go through the steps to get to this functional state. All right, so that's the actual Python script, and the only modified line, as you see, verify position equals set to false for the live run. I'm importing the pickle module, which I'm mostly using for debugging. I'm importing the CV2 for OpenCV library access, keyboard for sending keyboard actions, arrows in my case, MSS for screen capture, NumPy for NumPy arrays, which are used by OpenCV as frame representations. This is just a fancy library for logging that allows me showing success information, warning error in a very easy way. And finally, I also import a few functions to operate on Windows, in Windows, so that I can find them, find their position, and also relocate them. All right. Recognition threshold for a particular method that I have chosen. This was found by testing, so 0.95. Then I'm loading the images of arrow hints from the game, so left, right, up, down, which I've manually cut out from the screen captures. And here 10 pixels means that's white background boundary of this size. I'm also, upon reading, I'm converting them to the grayscale at the same time. I have a list of all the arrows which are possible that simplifies code further down. In this chunk of code, I'm determining the width and the height of all the loaded arrow images. I normally would only need it to draw boxes around the arrows that were detected. I didn't use it in production code, but that's still a leftover from testing runs. Now I also have the expected action counts, how many lefts, rights, ups, and downs I should have had during the entire game. Now, it's a good question where I got this from, and I will tell you. So the very first solution that I have found for the Dancing Machine challenge was an AutoHotKey script somewhere on the Steam game forums. And it could have worked, but it's essentially doing a sleep for a certain amount of time and then send the keystroke. And that, if you have even the slightest variations in frame rate, that becomes very tedious to adjust and adapt. And you also gain no knowledge by doing so. So yeah, I didn't go forward with that approach, but that's how I know how many actions have to be performed. Now I'm setting up some counters for how many actions were performed and the total number of actions, and I'm also getting the total number of actions that I expect. That's the exit condition for the script. I also have the frame counter. This is mostly for debugging purposes. And then I also have the actions counter by action, left, right, up, down. I also have a dictionary of scores per frame, and also the whole frames that are captured during the run of the script. They are essentially also saved. Good. Now we come to the capture area definition. During my testing, I found that I only need to look at that single circle kind of target at the bottom of the game window. And that's exactly the coordinates that I'm specifying down here. However, that assumes that the window is perfectly positioned, the Pikuniku game window, which I'm setting to 800 by 600 resolution. So I also have to do that in the code. As the command here says, if I simply detect the presence of the arrow, I can do so multiple times as the arrow is passing the target circle. So I have to stop that from happening, so I define the above threshold variable. Now, when the script starts, the first thing I will do is find the window called Pikuniku, find its current coordinates, print those, and then move the Pikuniku window to the top left coordinates, essentially 0, 0. This is for consistency of cutting out this target circle from the game runs. Now, actually, you can see this. I ran this again to reposition the window. So you see there was a position before, and that's the position afterwards. Now, there are better ways to do this. I could probably run in the full screen mode as well, and I could automatically find where the target is in the code, but I didn't bother. That wasn't that important for me. Now, this variable switches the script's operation in one of the two possible modes. One mode is verify position equals true. Will simply grab a single frame, convert it to grayscale, show a little OpenCV window, and wait for you to quit. This is just for confirming that you are capturing the right area of the screen. Now, this has been set to true for a few test runs before I was aligning the window. And as soon as I want to have the production run, I set verify position to false. And then this chunk of code is executing. Now, first of all, I have all of the code in this branch wrapped with a try, except keyboard interrupt. I wanted to have a way to end the script. For example, if the exit condition was wrong. And for that, I'm using the try except statement. And I also have the finally clause down here, which is doing several things. And the finally clause in Python in the try except statement is run both after the try code block if it was successful and also after the except code block if there was actually a keyboard interrupt, if there was a Control-C that I've sent to the terminal. So I'm closing all OpenCV windows. I'm also printing out statistics on how many frames were analyzed, what were the expected action values or count values and actual values. Then I'm also printing if actions sent by the script match those that I expected to get or they don't match. And finally, I'm doing two more things. If the script was to fail on this first live run, I wanted to keep the scores pickle, which essentially tells me what is the score for left, right, up, and down arrow detection per frame. And also, I would save the frames themselves as pickles. And you can actually see them. There's frames live pickle, and there's the scores.pickle files, which were indeed saved. Okay, so that's why I have the try except finally block. Now, I'm using the MSS library for screen capture, and it's awesome. It's very easy to use. It's high performance. I tried it before, so I can only recommend this one. Then I'm adding the loop exit condition. So as soon as I perform as many actions as I expect, this part would exit, and the script will terminate, as you have seen in the screen capture. I'm increasing frame counter by 1. I'm grabbing the specified screen coordinates, converting to grayscale, appending to my list of frames that I'm collecting for debugging purposes, showing OpenCV image of the captured area, and waiting as little as I can, in this case 1 millisecond. Then I'm setting up for each frame separately a dictionary of detection results. Here I'm doing the main meat of the detection. The CV2 match template function can use multiple methods to find your query image in your, let's say, database or captured image. So that's the methods I'm using in this case, and I did explore two methods before landing on this one. This will return evaluation of the match for multiple positions on the image. And if I wrap now these results into the min-max location, I can identify where is the highest score. So in this case, for Pikuniku game, I only have a single location where I expect the arrow to match. So I only need one result here. And as you see, I'm doing this detection for all 4 arrows, left, right, up, and down. And then I append the score for each value to a list within a dictionary of the scores. For different methods, you would need to capture different values. So for example, for this method, I need to capture the maximal value because that's the best hit. For some other methods, you actually need to capture the minimum value. And this function gives you both, and you have to decide which one to keep. Now, in these 2 lines, I am finding which exactly arrow had the highest score of all 4. And then that's the main logic of the script post detection. If the score that I'm observing is below the threshold, then I continue. But at the same time, I'm setting the special variable above threshold to false to prevent multiple actions if I'm seeing the arrow in multiple frames going through the target. If the maximum value is not less than threshold, but I have this variable set to true, we are above threshold, then I do nothing. I allow the arrow that we have already detected to go through the target without action. I wait for the score of the detection method to decrease below the threshold, this one. And finally, if score value is above the threshold, and I don't have above threshold set to true yet, we have a hit. We found an arrow detection with a score above 0.95. So here I'm just writing in the terminal that, let me find the message. So for example, down on frame 3960 with this score above the threshold. I'm just printing out this message. I'm setting above threshold true. We found the error and we should not press any keys anymore other than this one time. I'm also counting how many actions I performed on this particular arrow direction, and I'm sending the keyboard action, which is very easy. I just have to say up, down, left, right, underscore arrow on the keyboard library. And that's it. That's the whole script. There's nothing more to it than what I have shown. I do not plan publishing the script anywhere, but I think I have been going through it slow enough for anybody interested to re-implement and recode, and I think that would also be a great learning experience, also with OpenCV and everything else. However, I did not write the script from scratch. I actually had an entire Jupyter notebook exploring things before this happened. So in this last part of the video, I'm going to tell you what were the steps for me to make it work. So there you have it. It's the Dancing Machine challenge with a little bit of rather simple or very simple OpenCV code in Python working on the first try. That's it. The project is over and I can move on to the next project. Have a good day and maybe see you next time. Bye.